Hi, I'm Julia Claxton. I'm on the science team here on Glee, and let's talk about how our thermopile works. So first, let's identify where it is on the Lunasat. It is on the front side, and it's kind of near our RF antenna. It's highlighted here on the slide. And just an important note here, do not touch the sensor because it actually has a lens as part of how it works, and touching that lens could smear it and alter our data, and we just don't want to do that. So make sure to keep your hands off of that and make sure it stays clean. So let's talk about how it works. How do we get a temperature from a distance? It all depends on thermal radiation. So everything that has a temperature above absolute zero, so everything, naturally emits some electromagnetic radiation, and that's thermal radiation. And basically our thermopile takes this thermal radiation and converts it into a voltage, and then converts that voltage to a temperature reading. So with thermal radiation, the wavelength of the radiation is dependent on the temperature of the object. So most things that you encounter in your day-to-day life are emitting light below our visible range. So in the infrared range, and most things typically emit light in the infrared range. But as that temperature gets higher, there's more wavelength components in our visible range, and that wavelength gets smaller and smaller. And so the frequency of the light gets higher and higher. So for example, if you've seen something that's like glowing red hot, that's thermal radiation, just that the temperature has reached such a high level that its thermal radiation has crossed into the visible range. Same for like glowing white hot or even hotter. Basically, that's thermal radiation, and that's how we're converting it into temperature from a distance. So we do need to talk briefly about emissivity as well. This is a property of all of our physical objects that kind of relates its temperature to how much thermal radiation it emits. So for like an emissivity of 1, a black body, that means it gives off the maximum amount of thermal radiation for its temperature. Whereas like an emissivity of 0 means it emits no thermal radiation. Obviously that doesn't happen in the real world, but it's kind of a scaling factor that tells us how much thermal radiation something emits for its given temperature. So obviously this is an important thing to consider with our thermopile to make sure we're getting accurate readings, since we do depend on thermal radiation. So now let's talk about how we actually get thermal radiation into a voltage, because that's not straightforward, is it? So we've got to start out talking about a thermocouple, which is a little bit different than our thermopile. So a thermocouple basically is a temperature sensor, a very simple temperature sensor that has two dissimilar metals that are joined at a junction. And they basically, when there's a temperature at that junction, it creates a voltage difference across that junction, and that's proportional to the temperature difference between where you're measuring and that junction, as you can see in the diagram on the right. So then a thermopile is just a bunch of thermocouples put all together. And so basically we just have a bunch of junctions, and that all it does really is amplifies our signal, because if we only had one thermocouple, there could be a lot of error there because the signal levels could be kind of low. But the more thermocouples we add, the bigger that signal gets and the easier it is to measure. So there's a little less noise. So you might be wondering, what does this have to do with thermal radiation? And that's a great question. That's where the lens comes in. This is the part that we want to keep clean because it's actually very critical to how we measure the temperature in the thermopile. Basically, we put an infrared absorber or lens over the junctions of the thermopile, and then that incoming thermal radiation, infrared light, comes in and it's absorbed by that lens. And basically, that lens kind of converts that thermal radiation back into heat, which is measured by those junctions of the thermopile, which then creates a voltage difference. So basically, that lens is a lens for like a 1x1 thermal camera, 1 pixel. And that is how we create a voltage difference from incoming thermal radiation. And that's basically how it works. So we're going to move on to some activities and some code. And yeah.